Every day, thousands of smart devices, digital transactions, and IoT sensors generate massive volumes of raw information. As organizations scale, these trillions of data points multiply at a rate that outpaces traditional tracking. Inside a company, this volume causes severe structural issues. Teams end up downloading duplicate files, storing information in isolated silos, and using unapproved software to manage their daily workflows. To stay competitive, companies face a growing requirement to pool this information for advanced analytics and artificial intelligence. They must activate the data they collect to gain a market advantage. Warning tone. But if you connect a powerful AI agent to a massive, unorganized network drive, it will read everything it can reach. That includes personally identifiable information, financial records, and sensitive corporate secrets. Organizations find themselves trapped between competing priorities. They face pressure to adopt artificial intelligence rapidly, while simultaneously navigating strict legal requirements like the European Union's GDPR and health privacy rules like HIPAA. This comparative visualization shows the result of that friction. Notice the dual axes. 74% of organizations admit they cannot secure their data, while 68% report they are unable to even activate it for use. Traditional security approaches break down under these conditions. You cannot lock all your records in a disconnected digital vault because your analytics tools need constant access, and you cannot leave the network open to every user without violating compliance laws. Resolving this requires a system that acts like an air traffic control hub, routing verified information through secured pipelines to trusted users. This practice is known as data governance. This hierarchical chart illustrates the relationship between two distinct concepts. Data management is the broad foundation, the physical storing, processing, and moving of files. Data governance sits specifically on top of that, defining the oversight policies for data quality, security, and access. Governance relies entirely on human accountability. It starts with a steering committee, usually top executives who establish the overarching goals and privacy policies for the company. Beneath them are data owners. These are specific individuals who hold the legal and operational responsibility for distinct domains of information across various business units. Then you have data stewards. They are the personnel executing the tactical, day-to-day work to ensure specific datasets remain accurate, clean, and properly maintained. But while these roles establish a clear chain of command, human beings cannot manually review billions of files. They need automated tools to actually enforce their policies across a sprawling network. The first technical step is building a data catalog. Automated discovery tools scan the entire digital estate, finding and indexing every piece of information into a single, searchable inventory. On this node tree, raw data passes through a filter. The system applies labels marking it as public, confidential, or sensitive. The system also tracks data lineage. Tracing backward from a tagged point reveals its exact origin sources and every transformation it went through. This flow diagram illustrates how tags are used in role-based access control. When an AI agent attempts to pull information, the system instantly checks its permissions against the data's tag. It blocks access to restricted nodes and grants unrestricted ones. By combining automated discovery, detailed lineage tracking, and strict access controls, an enterprise can safely feed vast quantities of verified information into complex machine learning models. When these mechanisms are fully implemented, isolated data silos disappear. The organization operates from a single, verified source of truth. By replacing manual, error-prone permissions with automated, policy-driven tags, administrators close the security gaps where breaches typically happen. This shift to a data-first security model accounts for the 30% reduction in the likelihood of a breach observed in governed environments. This efficiency extends to the balance sheet. When data scientists spend less time searching for data and more time deploying it, project cycles shorten and storage redundancies disappear. Organizations report that this accelerated deployment leads to a return on investment of over 350%. An artificial intelligence system is only as smart, fair, and legally compliant as the information used to train it. A functioning data governance program provides the verified inputs required to make those systems reliable. It establishes the operational guardrails that make long-term digital innovation possible.